Hi students, good morning. Welcome to this video session. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video, we shall continue from where we stopped in part 1. This would be the part 2 of CSEC theorems. So please, it is important that before you start viewing this video, that you view part 1 already. That you view part 1. It's a playlist. If you go to this website, www.samdomforpeace.com, you click on CSEC theorems, and you will see the video link, and you click on that. It's a playlist. So this will be the part 2. Then the questions we are going to solve, you click on solve the examples. If you click on the solve the examples link, there's a link. You click on solve the examples and you will see these questions. So like we did in part 1, I will draw the circle and I will verbally explain the reason. We are going to solve it, but we are going to verbally explain the reasons rather than writing down the reasons. Why? Because it has already been written on the website. So if you go to the website, as you're viewing the video, it's good to look at the transcript from the website. So instead of writing down the reasons, because for anything you do in CSEC theorems, you will have a reason. You have to state your reason. Okay, we discussed that in part 1. So we are going to just verbally explain the reasons, and we touched on those. We touched on some CSEC theorems in part 1, so we are going to be using those as well. We are going to state another theorem. Like I said, there are so many, but we are doing it in bits and pieces, okay, in chunks. So let's state another theorem. This will be theorem 8. We stated about 7 theorems in part 1. We'll state another one, theorem 8, and then we solve more problems. Okay? So theorem 8. Theorem 8. Number 8. This theorem states that we stopped at tangent. Okay, in the part 1 of the video, we looked at a tangent to circle. We stated that the radius is perpendicular to tangent at the point of contact or the point of tangency. Then we stated that two tangents drawn from the same external point, two tangents drawn from the same external point are equal in length. Okay. So still on tangents, we want to state the theorem 8. And it states that the angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, in part 1 we described what is segment, what is chord, what is sector. We did that already in part 1. So it's important you view part 1 first. Okay. The angle between a tangent and a chord is equal to the angle in the alternate segment. That is this theorem. So what we are saying is this, okay? If I have let's look at some examples. So let's say I have a tangent. Let's say I have a tangent. So what this is saying is that, and if I have a chord, what this theorem is saying is that the angle here between the tangent and the chord, okay? Let me say I have chord AB and tangent CAD. Tangent CAD and then chord AB. So what this theorem is saying is that this angle between a tangent and a chord is equal to the angle in the alternate segment. So here, as you can see, this chord divides the circle into major segment, minor segment. So this is the major segment, minor segment. So as you can see here, this angle is in this segment. You know, it's part of this segment and also outside it. Okay, as you can see this angle. So what it's saying is that this is now the alternate segment right here. That the angle between this chord and this tangent, if I have to draw a triangle, okay, it's equal to this angle here in the alternate segment. That is what it's saying. So if I have this as x, this will be x. And if I have this as y, if I can call this y, then this here is also y. That is what this theorem is saying. That the angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, let's give another example. If I draw a circle, let's say we have the tangent here. Let's say we have a tangent here. So, if I have a chord, let's say I have a chord here, what this theorem is saying is that the angle between this chord and this tangent, so this angle right here, the angle between the tangent and the chord, then I have to draw a circle, okay? I've got to draw a circle, okay? The angle between this tangent and the chord is equal to the angle in the alternate segment. Angle between a tangent and a chord, okay, is equal to the angle in the alternate segment, this angle. And if I'm looking at this angle here, the angle between this, now if you're looking at this now, let's call this here M. So if I have this as M, this is also M. Now, what if I have this here, the angle between, this is another chord, and this is the tangent. The angle between this here, the angle between this chord and this tangent, let me call it a P. Then you see, with this circle here, it will be equal to the angle in the alternate segment, P here. You see that? So, that is how it works. Now, what if somebody asks me, I say, hey, Mr. C, what if you're considering this angle here? Here. Let me use double lines. Okay? What if you're considering this angle here? The angle between this tangent and this chord. So, let me call this angle K. What will it be? Okay, so look at, because this is the technique. So you look at this angle between the tangent and the chord. You now make this chord as a triangle, like from here, you draw a triangle here. And this is going to be equal to this angle here. K. This will K. That is the way it works. That is the way it works. So you have a chord, you have the tangent, you find the angle, then complete a triangle there, and it's equal to that angle. Okay? And then if I'm looking at this way, what is this angle here? If I have triple lines, just to tell you it's another angle. Let me call this angle G. If I have angle G, then you see the angle between this chord and this tangent. This is a triangle here, and it's going to be equal to this angle here. Angle G. That's the way it works. That is how it works. The angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, that is theorem 8. All right, but don't worry, when we solve more problems, you will understand it. Okay, as usual, we shall continue we're going to continue from I have to tap my laptop because I'm getting, like I said, this is already on my website. So I am bringing the questions from my laptop. Okay, I'm not using any paper. I'm using I'm getting it right straight on from my website. So the questions we are going to solve are all examination questions. Past examination questions from WASSCE, West African Senior School Certificate Examination, from the Caribbean Secondary Examination, CSEC, CSEC, I call it CSEC, from JAMB, okay, Joint Admission and Matriculation Board. So that's the past questions. Now, we're going to do more theorems and we will solve problems from ACT. Okay, but the questions we'll solve tonight, the questions we're going to solve tonight, or today as you can call it, well, it's day. I said good day. Okay. Well, the questions we'll solve today are all past question papers. Okay, from WASSCE, from CSEC, and from JAMB. When we do more theorems, we're going to solve problems on the ACT as well. Yeah, but let's see how many questions we can solve, because the main thing about circle theorems is you know, I've explained the theorem. Okay. However, you need to solve a lot of problems for you to grasp it, for you to grasp all these theorems. Now, so far we have explained 8 theorems. So like I said in part 1, I don't want to state all the theorems, give it to you, and it's a lot, and then begin to solve questions. No, we've stated 8. We stated 7 in part 1, and we solved about 4 questions in part 1. So this, now we are stating the 8th one. Let us solve a lot of problems, a lot of questions. That way, by the time you solve a lot of problems, you will understand it, honestly. Circle theory is not difficult. Okay? So I thank God for giving me the talent to teach it well. It's not difficult. Okay, let's now solve problems. Hopefully you have viewed part 1. So, because when I verbally state the theorem, you know, okay, hey, this is what we're applying. Like when I state the reason, okay? So number 5 question. Question 5. Because we solved 4 questions in part 1. So now we are starting from the 5th one. And it's a WASSCE question. I have this circle here. Have it this way. Please don't laugh at my diagrams, okay? Don't laugh at me. P, K, R. P, K, R. Then I have O. And then 20 degrees, 108 degrees. 108 degrees. And here is 20 degrees. And they want you to find this. Okay. In the diagram, O is the center of the circle. POR. Angle POR is 108 degrees. And angle ORK is 20 degrees. Calculate angle OPK. OPK. That's this. Okay, so we can we know here already, okay, we know that base angles of isosceles triangle, okay, because this is always the center of the circle, so this is a radius and this is a radius, okay, that's a radius, that's a radius. So what we could do is this. Let's complete this. Let's complete this like a triangle. Let's complete it. And because this is a radius, this is a radius. This angle here is equal to this angle. Let's call it y. Y. Okay? You see what I just did? Yeah, because it's base, we call it the base angles of isosceles triangle. Base angles of isosceles triangle. So let's go ahead and then we can also get this angle. Let's get this angle first. Let's get that angle first. Okay. So from this angle here, angle PKR. Angle PKR will be 108 divided by 2. Okay, because angle at center, this is 108. 108 is equal to 2 times angle PKR. Reason, angle at center is 2 times angle at circumference. So angle PKR will be 108 over 2, which is 54. Please, I explained this very well. If you look at the way I solved it, you tell me whether I explained it well or not. And I think I did. Okay? So I just want you to pay attention and listen. I have already explained it. Okay? And like I said in part 1, some of the questions, you know, you pause the video, do it first on your own. Then you can check your answer with mine. Okay? Okay, so this 54. This 54 degrees. So we can now find y, and then after finding y, we can now find this. Okay? So let's go ahead and find y. Considering triangle POR. Considering triangle POR. Okay. Because this is radius. This is a radius. So because it's a radius, it's base angles of an isosceles triangle. So we see that y plus 108 is equal to 180 degrees. Now this y is equal to y. Reason, base angles of isosceles triangle. Then y plus 108 is 180 degrees. Reason, sum of angles of a triangle. Okay, so we now have 2y is 180 minus 108, which is 72. So y is 72 over 2, y is 36 degrees. Okay, so this is 36, this is now 36, this is 36. Okay, so let's call this x, let's call this one x. Like what we want to find. We are asked to find angle OPK. So let's call it x. Okay, OPK. So now we are going to consider triangle. Considering triangle PKR this time. We now have that x plus 36 plus 54 plus 20 plus 36 is equal to 180. Considering triangle PKR, the whole thing, the whole triangle here. Reason, sum of angles of a triangle. So 36 plus 36 is 72. 72 plus 72 plus 74. Okay, is 146. So x is 180 minus 146. And this is 4 and this is 3. So angle OPK is 34 degrees. That's the answer. Angle OPK is 34 degrees. Okay? Does that make sense? Alright. Let's do the next one. Let's do the next one. Question 6. Question 6 is WASSCE also. So I have the circle. And I have this here. So I have x, 2y, 2x, and 60. That's 60. Right? Okay, that's 60, yeah. So I have x here, x degree, here 2y degree. This is a WASSCE question. 60 degrees and then 2x degree. I have 60 degrees and then here 2x degrees. Okay, they say find the value of y in the diagram. Find the value of y. Okay, so looking at this straightforward, x is equal to 2y. X is equal to 2y. Reason, angles in the same segment. Angles in the same segment of a circle are equal. Alright, here we can find this angle here, Okay, we can call it P. We can call it P. We can call this angle P. So we can label this triangle because we want to find 2y. We want to find 2y. So let me label this as ABC. ABC. Now, P plus 60 is equal to 180. Reason, angles in a straight line. Angles in a straight line. So P will be 180 minus 60, which is 120. Now I have to consider triangle ABC. If you consider triangle ABC, then P plus 2y plus 2x is 180. Reason, sum of angles of a triangle. Sum of angles of a triangle. So we see here that x is 2y anyway. They want us to find y. So I will not bother finding x. I am interested in y. So substitute x equal to 2y here. Okay. So our P is 120 plus 2y plus 2 times our x is 2y. 2 times 2y equal to 180. Okay, so we now have 120 plus 2y plus 2 times 2y is 4y equal to 180. So 6y is 180 minus 120. 6y is equal to 60. And y will give you a 10. Y is 10. Okay? So your y is 10 degrees. Y is 10 degrees. Alright, we have many questions to solve. So you can pause this and write, but otherwise we'll keep moving because we have many questions to solve. Question 7 is the next one. Question 7 is CSEC. Question 7 is CSEC. The diagram below, not drawn to scale, shows a circle with center O. Okay, let's draw the diagram first. Question 7 is CSEC. So it looks like we have 2 tangents. Yeah. We have another one. 2 tangents. Then we have 48 degrees here. H, J, G. Then we have a chords. We have a chord here. Yeah. Okay. Okay. Looks like we have a cyclic quad. Cyclic quad. And this is L. Then we have the center O. Alright. The diagram below, not drawn to scale, shows a circle with center O. Circle with center O. HJ and HG are tangents to the circle, and angle JHG is 48 degrees. Angle JHG is 48 degrees. Calculate, given the reason for each step, they want us to calculate angle OJH II, angle JOG III, angle JKG, and then IV number 4 angle JLG. Okay. OJH, OJH, OJH. So they want us to find this angle right here. They want us to find that angle, OJH. We know that the radius is perpendicular to tangent at the point of contact. So this is a tangent. HJ, they say HJ is tangent. HJ, yeah, HJ and HG are tangents. I know they are tangents, I just wanted to make sure. So the radius is perpendicular to tangent at the point of contact. O is the center, so this is the radius. So this is actually a right angle here. Radius is perpendicular to the tangent at the point of contact. The point of contact is J, or the point of tangency is J. So angle OJH is 90 degrees. Reason, the radius is perpendicular to tangent at point of contact, or you can say at point of tangency. Then the next one is angle JOG. JOG. So this angle here, this angle right here, angle JOG. So with this, we can do something here. This here is also 90 degrees. This here is also 90 degrees. Okay? That is also, this is also 90 degrees, as you can see, because radius is perpendicular to tangent. So angle OGH is also 90 degrees. Radius is perpendicular to tangent. So we can now find angle JOG, because this is now a quadrilateral, not a cyclic quad, okay, but just quadrilateral. And then the sum of the interior angles of a quadrilateral is 360 degrees. Because quadrilateral is four-sided polygon. So, with quadrilateral JOGH. So we now see that 90 plus, let me call this X. Let me call it X. 90 plus X plus 90 plus 48 is equal to 360. Reason, the sum of the interior angles of a quadrilateral is 360 degrees. Okay? Now there's another way we can do it, but that would be a longer way. The shortest way would be to do it by this reason. Okay? So this is a 180 plus 48 is a 228. So X is 360 minus 228. This is 2. This is 3. 132. This is 132 degrees. X is this is 132 degrees. Okay, 132 degrees. The next one is angle JKG. JKG. So this angle right here, this angle here, oh, that's pretty straightforward. This is 2 times this. Okay, this here is 2 times this. So let me call this Y. If I call it Y, then we have that 132 is 2 times Y. Reason, angle at center is 2 times angle at circumference. We explained this in part 1. We explained it in part 1. Okay, angle at center is 2 times angle at circumference. So Y is 132 over 2, which is 6, 12, 66 degrees. So this is 66 degrees, angle JKG. And then the last one, angle JLG. JLG. So this is 66 degrees. Now JLG, that is this here. JLG, that's this angle. Okay, let me call it P. Now let me call this reflex. So here is also angle at center, but like I explained in part 1, you have to find this reflex first. You have to find the reflex first. So let me call this reflex G. So G plus 132 is equal to 360. Reason, angles around a point. So G is 360 minus 132. This is 8. 5 minus 3 is 2. 3 minus 1 is 2. 228. So now G, that 228 is equal to 2 times P. 2 times P. Reason, angle at center is 2 times angle at circumference. Okay, you see the way it looks? Like we explained in part 1, see how it looks. This goes like this, because it goes this way. You see, this one goes like this. And then this one goes like this. Okay, see that? So P will now be 228 over 2, which is 114 degrees. So this is 114 degrees. That's it. Okay? Alright, folks, we still have a lot, we still have many more questions to solve. So let's do question 8. Next one. Question 8. Question 8 is WASSCE. Question 8 is WASSCE. So it's pretty straightforward, right? Are you understanding it? Are you understanding it? Question 8 is WASSCE. We have the circle here. This is also a cyclic chord. Although we didn't use cyclic chord in previous one. We just use quadrilateral. We have this. So here PQRS, PQRS. Then we have this like this. Center O. We have 20 and then 65 degrees. So we have 65 here, 65 degrees here, and then we have 20 degrees here. Oh, sorry, not 20. Yeah, because that's, I'm kind of, it cannot be 20, that's a reflex angle. X. I'm looking at the diagram. I'm sorry. Yeah, I'm like, oh no, it can never be 20 because that's reflex angle. Okay. Reflex angle is greater than 180 degrees but less than 360. Alright, so this X, it says in the diagram, O is the center of the circle, PQRS. And angle PQRO is 65 degrees. So PQR, okay? Find the value of the angle X. Find X. Okay. Oh. This is straightforward. This is very straightforward. Very straightforward. So, if I call this Y, this O, if I call this Y here. So Y is equal to 2 times 65. And that gives you 130. Reason, angle at center is twice angle at circumference. Okay, angle at center is twice angle at circumference. So then X plus Y is 360 degrees. Reason, angles around a point. So X is 360 minus Y, and our Y is 130. So this is X is 230 degrees. That's it. That's it, folks. That's it. Question 9. That's it. That was really fast. Okay. Question 9 is WASSCE theory. WASSCE theory. WASSCE theory. I mean, you know, here is JAMB is multiple choice. WASSCE is both multiple choice and theory. And then CSEC is theory. So the ones that are multiple choice, I put the multiple choice options to guide you. Okay, but I'm not gonna come and start listing the options here, no. What I'm doing here is like verbal explanation for those students who prefer, you know, some students are verbal learners and they are visual learners. They want to see what you're doing actually, and they want to hear you speak, explain the reason or show something, you know. So that's the essence of doing these videos. So here we have this. We have the circle. We have this, yeah. We have a chord here, a chord here. Have another chord here. Then have the center. I think I'm trying with my diagrams, right? I am trying with my diagrams, with the diagram. Okay. Oh, this is 252 degrees here. Okay, and we have that here and here parallel. This and this are parallel. Sorry, not parallel. Hey, sorry. They are congruent, they are equal. Okay, they are equal. So we have a PQRS. PQRS. RS. And we have X degrees here. X degree. Okay, so it says here in the diagram, O is the center of the circle. O is the center of the circle PQS. Circle PQS. O is the center of the circle PQS. SR is a tangent. Okay, that's a tangent. Reflex POS is 252 degrees. Reflex. Okay? That's right. And angle SQR is 79 degrees. SQR is 79 degrees. So this will be 79 degrees. Angle SQR. Angle SQR is 79 degrees. Okay, although you didn't put it in the diagram. Calculate the size of angle QRS. Angle QRS, so X. Find X. Calculate the size of angle QRS, which is X. Alright. Okay, so can we do something, folks? We are looking at radius and tangent. Okay, so here is 90 degrees. Angle OSR is 90 degrees. Reason, radius is perpendicular to tangent at point of contact. Radius is perpendicular to tangent at point of contact. Okay? Then we see something here. Because we're interested in this X. That's our interest. That's our interest. So can we do something? Can we come and draw a triangle? Can we draw a triangle there? Okay. Can we draw a triangle there? And we see, now this is the center O. So let me just write the center O here. Okay, let me write the center O right here. So we see that this here is equal to this here. Okay. Angle OPS is equal to angle OSP. OSP. Let's call it Y. Let's just call it Y. Reason base angles of isosceles triangle. Because this is a radius, this is a radius. Okay? So they are equal. Base angles of isosceles triangle. Okay. Now, this is the reflex here, 252. Let me write it like this, 252. Right? So, see, we are trying to, if we can get this angle here, If we can get this angle, then our problem will be solved, because we will now consider triangle XQR. If we can get this angle. Okay. So whatever we are trying to do now is to get this angle. So we can get this angle here. We can get this angle here. Then from here we can get this angle. And once we get this angle, this here is also congruent. Okay, this is also congruent. We can get this, and then we can subtract from 90 to get this here. That's what we can do. That's what we're, in fact, that's what I think we should do. Okay, so let's get this angle here. This angle here, obtuse angle is an obtuse angle. Obtuse angle POS plus the 252 reflex will give us 360. Reason angle around a point. Angle around a point. So this obtuse angle POS is 360 minus 252, and this is 108. 108. So this is 108 here. 108 degrees. 108 degrees. So we've had this, we can have this here. 108 angle PQS. Angle PQS 108 is 2 times angle PQS. Okay, this 108 is 2 times angle PQS, this angle here. Reason, angle at center is 2 times angle at circumference. So angle PQS is 108 over 2, which is 54 degrees. 54 degrees. So this is 54 degrees. Okay? Now we can get, we want to find, let's find our y. Okay, let's find our y first. Let's find our y first. After finding our y, then we can get this. We can get this angle. And once we get this angle, actually, this will be, we can get this right away, because this will be angle between a chord and a tangent. Okay? And from there we solve our question. Alright. Yeah, this one is taking a little bit of more time, but that's okay. Considering triangle POS. Triangle POS. So y plus 108 is 360. I mean, sorry, 180. So, considering triangle POS. So y plus 108 is 180. Reason, sum of angles of a triangle. So 2y is 180 minus 108. This is 72. So y is 72 over 2. Y is 36. So this is 36 here. 36. And this is 36. Okay? Alright. Now, let's go. Now, this is, the PQ is congruent to QS. Okay, PQ is equal to QS. Line segment PQ is congruent to line segment PS. So this here is also equal to this here. So this here is also equal to this right here. Okay, but let's get this. Let's call this G. Okay? So considering triangle PQS now. Considering triangle PQS, the whole of triangle PQS, we now see that 36 plus G plus 36 plus G plus 54 is equal to 180. Reason sum of angles of a triangle. So this is a 2G plus 72 plus 54 is a 126. Okay? So 126 is equal to 180. So 2G is equal to 180 minus 126. This is a 4. 7 minus 2, 5, 54. So G is equal to 54 over 2, which is 27. So this is 27 here. 27, and this is 27. Okay? So 54 plus 72. Okay, just to check this, 108 plus 72, yeah, 54 plus 54 times 3 is 108. Okay, sorry, 54 times 2, I mean, 54 times 2 is 108, then plus 72, that's 180. Okay, because this here is congruent, that's why they're congruent. Okay, that is what it means. All right, we can now do this any two ways. Okay, we can do it any two ways now. We're almost done with this. We can say that angle QSR is equal to this here, 36 plus 27. Angle QSR is equal to this angle. Reason, theorem 8. Angle between a chord and a tangent is equal to the angle in the alternate segment. This angle is equal to this angle. Angle between a chord and a tangent is equal to the angle in the alternate segment. So this will give us a 36 plus 27 is 63. So this is 63 here, 63 degrees. Now we can find our x. Another way we can get 63. Do you know another way we can get 63? We can do 90 minus, because this whole is 90. So we can do 90 minus 27. We can do 90 minus 27. Or we can also do, because this whole here is 90, then minus 27. 90 minus 27, and that gives us 63 also. So any way you want, you get that 63. Now we can now find our x. So 63, now considering triangle QSR. 79 plus 63 plus x is 180. Okay? So 9 plus 3 is 12. 7 plus 6, 13 plus 1, 14. Plus x is 180. So x is 180 minus 142. And that is 38 degrees. 38 degrees. X is 38 degrees. Question 9. Ooh, I got that. I got the basketball, the shooting on the basketball. Okay, I gotta log in again because my computer said, hey. Okay, so we just finished question 9. Let's go to question 10. Question 10. Question 10 is JAMB. Jambito. Jambites. Jambites. Is it making sense at all? Hope this is making sense. Comprender? Comprenez-vous? Una otaraya? So I said, comprender? What language? Okay. Do you understand? You know, tell me the languages. Number 1. I'll start with my mother tongue, of course. Number 1. Una wataraya. Una wataraya. Una wataraya. That's number 1 language. Yes. I'm proud of my language. Number 2, do you understand? Number 3, comprender. Number 4, comprenez-vous? Okay, question 10, we have this circle. So we have something that like this actually. We have a card here. We have another card here. Have this. This cube. This is 30 degrees. 30 degrees. This is x degrees. This is P. This is T. And we have this here. This goes here. 4. Okay, looks like this is the x here. Like this x is what this x should be here. Looks like that. X degrees here. And we have x here. X degrees here again. And we have 2x. 2x degrees. Okay. So it says here in the figure above, PT is a tangent, okay, to the circle with center O, okay. If PQT is 30 degrees, PQT is 30 degrees, find the value of PTO, PTO. So this is what they are looking for, PTO. So this is here. 2x degrees. 2x degrees is what they are looking for. 2x degrees. Okay, so we have a tangent and we have the radius. So this is 90 degrees. Radius is perpendicular to tangent at point of contact. Radius is perpendicular to tangent at point of contact. Do you understand what I'm saying? Now, and with JAMB questions, you have to do it. I mean, your target should be at most 2 minutes, at most, okay? But my guideline will be 1 minute, to do this within 1 minute. So, but because I'm teaching this, you know, I'm taking more time, but I can do this in less than 1 minute, okay? So, but here, because I'm kind of explaining this, okay, I'm not in an exam condition. I am teaching. So, as you can see here, Anytime you see a center, you see a radius, and you see tangent, just know they might want that application, that theorem. They might want that theorem. So angle OPT is 90 degrees. Reason, radius is perpendicular to tangent at point of contact. Now let us consider triangle, because we can get this right away. So consider triangle, PQT. Consider triangle PQT, everything. So we now have that 30 plus x plus 2x, okay? This is the x plus 2x here, plus x plus 90 will give you what? 180 degrees. Reason, sum of angles of a triangle. Sum of angles of a triangle. So this is 30 plus x plus 2x plus x plus 90 is 180 degrees. Okay? So this is a 4x. X plus 2x is 3x plus x, 4x plus 120 is 180. So 4x is 180 minus 120, which is 60. So x is 60 over 4, which is 15. X is 15 degrees. And guess what? You're rushing in JAMB. Hey, I got it. You look at the option, you see 15. You look at the option, you see 30. And you rushed and checked 15. But they asked you for PTO, 2x. See that? So you have to do 2x, 2 times x is 2 times 15, which is 30. Because then you rush, hey, see 15, you see 30, and you rush. Okay? So that is it. Next one is question 11. Question 11. Question 11 is JAMB. JAMB. Another JAMB question. So we have a circle here. We have a cyclic porch. We have a tangent. We have something here. We have a tangent. The circle. And this is a PQRS. Looks like these folks like the PQRS. So we have this is congruent to this. We have PQRS. PQRS. And this is 50 degrees. This right here is 50 degrees. Okay. It says here, PQRS is a cyclic quadrilateral in which PQ is equal to PS. Okay? PT is a tangent. PT, yeah, there's a T here. PT is a tangent to the circle. And PQ makes an angle of 50 degrees with the tangent, as shown in the figure below. What is the size of QRS? What is the size of QRS? So this here, QRS. You know, you can write it like this, or you can write it this way. Either way is fine. Okay? What is the size of QRS? Please do not be tempted to say that this is 50 degrees, because that is what some people might say right away. And they will say angle between a chord and a tangent is equal to the angle in the alternate segment. I don't want you to do that. Remember when I explained this theorem, I said you have to draw a triangle. Now this is a cyclic chord. This is what I'm saying here. If you have this theorem and you want to do angle between that theorem 8, angle between tangent and a chord is equal to angle in the alternate segment. It has to be that this here is this is the chord here. This is the chord, and you have to draw a triangle. You have to draw a triangle for it to work. So it has to be like this. It has to be like this triangle. If you draw a triangle, then this is what I'm saying here, that this is 50 here, that this will be 50. That is what I mean. Has to be a triangle. You have to draw a triangle. You don't just do it like that. No, you have to draw a triangle. So here angle PSQ is 50 degrees. Reason angle between a tangent and a chord is equal to the angle in the alternate segment. Now because these are congruent, angle PQS is also equal to 50 degrees. So this is also equal to 50 degrees here. Reason is base angles of isosceles triangle, because they said in the question that P, and they even put this here to show the congruency. Okay, PS is equal to PQ. So angle PQS is also equal to 50 degrees. Reason base angles of isosceles triangle. Now you can find this angle here. Okay? So angle SPQ is 180 minus 100, because 50 plus 50 is 100 plus this 1 plus x. Okay? I'm doing it like JAMB way, but if I do it, if I take my time, x 50 plus 50 plus x. If you consider triangle SPQ. If you consider triangle SPQ, then 50 plus 50 plus x is 180. So 100 plus x is 180. So x is 180 minus 100. X is 80 degrees. Now this reason is sum of angles of a triangle. Okay. So this is 80 degrees. Now you consider, to find this angle, you consider cyclic chord. Consider cyclic chord PQRS. Cyclic chord PQRS. So if I call this y, okay, 80 plus y is equal to 180 degrees. Reason, the sum of the interior opposite angles of a cyclic chord is supplementary. Okay, it's 180 degrees. The sum of the interior opposite angles of a cyclic chord is 180 degrees. We discussed that in part 1. It was one of the theorems we discussed in part 1. So y is 180 minus 80, so y is 100 degrees. 100 degrees. That's your y. That's this here. Angle QRS is 100 degrees. Okay? So please take note. the angle between a tangent and a chord, please, it has to be a triangle. You have to draw from that chord, draw a triangle, and then it is that angle in the alternate segment. Okay? Question 12 is the next. Question 12. Question 12. I hope this is making sense to you. I hope it is making sense to you. Question 12. Question 12 is WASSCE. WASSCE theory. WASSCE theory. So we have a circle. We have the center. A semicircle. We have a semicircle. Okay. Yeah. We have this. Yeah. Have this. And from this you have this. Yeah. This is parallel to this. A, B, C, D. And then this here, we have a transversal. We have a transversal here, and this is 48 degrees. All right. It says this in the diagram. O is the center of the circle. OC, line segment OC is parallel to line segment AD. Line segment AB is a straight line, and angle OCA is equal to 48 degrees. Calculate angle ABC. Calculate angle ABC. So this angle ABC, they want us to find this angle here. Okay, please, you look at this. A common mistake that some students will make is to call this a cyclic quad. When we talk of cyclic quad, we are looking at a circle. The vertices, the four vertices touch the circumference of the circle. We're not talking about a semicircle. We're talking about a circle. Okay, so let's look at what we're going to do with this. This is a center and it's a semicircle, so you have to think about the theorem we did. Angle in a semicircle is a right angle. It's 90 degrees. So we see this here. Here it's going to be 90 degrees. Okay, so you say angle ACB is 90 degrees. Reason, angle in a semicircle. Angle in a semicircle is 90 degrees. Then we want to find, because we found this angle, so if we can find this angle, that would be really good. If we can find this angle, that would be nice. So we can easily find angle B. Okay? We see that this is a transversal, this is also 48 degrees. 48 degrees. Although it might not make any, like here, angle CAD is 48 degrees. Angle CAD is 48 degrees. Reason alternate angles. Alternate angles, because this is a parallel line. OC is parallel to AD. I have a transversal that cuts it. So these are alternate angles are Z angles. Okay. But we need to find this. That's the main thing though. The main thing is to find this. So we can say, because this is a radius, this is a radius, and this is a radius. Okay? OC, OA is equal to OC. OA is equal to OC. This is a radius, this is a radius. So this is 48 degrees here. 48 degrees. 48 degrees. Reason, base angles. Base angles of isosceles triangle. Base angles of isosceles triangle. Okay, so we probably won't make it of this 48. We will not. Okay. So now we now say, considering triangle ABC. Considering triangle ABC, we have that 48, let's call this x. So 48 plus x plus 90 is equal to 180. So x plus this 138 is 180. X is 180 minus 138. 10 minus 8 is 2. 7 minus 3 is 4. 42 degrees. 42. So this is 42 degrees. Okay? That is it. 42 degrees. Question 13. We are getting there. We have so many questions to solve. I hope you're ready to stay with me, right? Are you ready to stay with me? Are you ready to stay with me? Ooh, I missed that one. Okay. Question 13 is CSEC. CSEC. Question 13 is a CSEC. Let's draw the diagram first. We have a circle. We have a tangent. Okay, so we have a cyclic quad. Okay? At least you know what I mean. It is always good to draw your diagram well, honestly, so that you will not mess up. Then we have something here. Oh, the center of the circle. Okay, we have a L, J, K, L, J, K, L, H. So we have J, K, L, H. And And then we have M, P. M here, P. Okay. Then we have here 20 degrees, 50 degrees. Here we have 20 degrees. And here we have 50 degrees. All right. The diagram below, not drawn to scale, shows a circle with center O. The vertices H, J, K, and L of a quadrilateral lie on the circumference of the circle, and PKM is a tangent to the circle at K. Tangent to the circle at K. K is the point of tangency, or the point of contact. The measure of angle HJL is 20 degrees. HJL and HJL is 20 degrees. And JKH is 50 degrees. JKH is 50 degrees. Okay? Calculate given reasons for each step of your answer. The measure of I, HKL, HKL, II, JOK, JOK, III, JHK, JHK. Okay? Oh, missed that one. That's okay. All right, folks, let's do this. I think that is it for this one. Let us see what they want here. HKL, HKL. So this angle here, this angle right here, HKL. Okay, I see it. Do you see it with me? Do you see it with me? Look, do you see it with me? Let's do this. Do you see what I'm saying? 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 So this is 20 here. This is 20 degrees. And this is what they're asking you for. Can you see that? Can you see that? So, you know, it's good when you have it like this, you know, it's, this is H, J, K, L. This is what they're asking you for. Right away. Please, don't be confused with the O, that one coming to O, no. We did this in part 1, angles in the same segment. We explained it in part 1, okay? So, HKL is 20 degrees. 20 degrees. Reason, angles in the same segment. Angles in the same segment of a circle are congruent. Okay, they are equal. So this is 20 degrees here. Alright, next one, JOK. 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 JOK is this one. JOK is this here. I see something too. I see something. Do you see it with me? Do you see it with me? Because this is O. From the diagram, Okay, from diagram O, from this diagram, see, this is base angles of isosceles triangle, because this is radius and this is radius. See that? This is radius, this is radius. That's for J, okay. So we can say that in considering triangle JOK, considering triangle JOK, JKO, angle JKO is equal to angle KJO, and that should be 50 degrees. So this here should be 50 degrees here. This 50 degrees. Reason, base angles of isosceles triangle. Base angles of isosceles triangle. That's the reason. Okay. Now, we now say, if we can call this x. So we have that now x plus 50 plus 50 is 180 degrees. Reason, sum of angles of a triangle is 180 degrees. So x plus 100 is 180. X is 180 minus 100, which is 80 degrees. So angle JOK is 80 degrees. So let's put 80 degrees here, 80 degrees. Right? The last one here, JHK. JHK is this angle right here. JHK, this angle here. JHK. So this angle here. Okay, so we would have just considered triangle JHK. We know this angle anyway, but we don't know this small angle here. We don't know this small angle here. So that becomes a little problem for us. Okay? Because we don't know that small angle. And please, but then we can use, guess what we can use? Angle in a semicircle. Okay? Let me be sure of this diagram again. Yeah, that's it. Yeah, angle in a semicircle. So this here is 90 degrees. The whole thing there is 90 degrees. So angle, considering well, this we don't need to consider the triangle here. We just say angle HJK is 90 degrees. Reason, angle in a semicircle. Angle in a semicircle. So this angle here would be 20. Okay, this small angle. Yeah, but we don't really need it. We don't need it because they're asking for JHK. So now considering the triangle JHK, we see that if we call this P plus 90 plus 50, okay, is equal to 180. So P plus 140 is 180. So P will be 180 minus 140, 40 degrees. So this is 40 degrees. 40 degrees. And that's it. That's it. That is it. It's pretty straightforward, right? Okay, let's do question 14. We have several, we still have several to do. We still have several. Question 14. Question 14 is WASSCE multiple choice. Okay? we have the circle. You know, when you do varieties, when you do a lot of varieties, it makes more sense when you do a lot of varieties. So you have this, have that going like this. You have this here. You have this here. P, S, T, Q, R. And this is 31 degrees. And this is 58 degrees. Okay, so it says find the value of angle TSP. Angle TSP. Angle TSP. Angle TSP. So this here. Find the value of angle TSP in the diagram. Alright, there might be so many ways. Of course, there are ways to solve this, but we are looking for quick way, fast and accurate. Because for these multiple choice problems, your target should be a minute to solve it. We see that this angle is also equal to this angle. Angle in the same segment. Angle in the same segment. Okay, we see that this angle TSP is the same thing as angle TQP. TSP is the same as angle TQP. Angle TQP. Let's call it X. Okay? Reason, angle in the same segment. Angle in the same segment. Okay? And this is also 31. But I don't think I need 31. Okay? I don't think I need it. So let's see what, if we can find X, we see actually considering triangle TQR. Okay? See what I mean here? I'm trying to treat TQR if we bring it out. So this is what I mean here. Do you notice something? This is X here. And this is 31. And this is 58. Do you notice something here? Do you notice something with triangle? Exterior angle of a triangle is the sum of the two interior opposite angles. Okay? Because if you're doing circle, you have to know triangles. It's important. It's important you know triangles. So go to get triangle theorems. You have to go to let me write another website here. Trigonometry.appspot.com. Okay? Trigonometry.appspot.com. So, because you need to know triangle theorems. It makes it easy as well. Trigonometry.appspot.com. Or you can just go also to www.samuelchukwuemeka.com or www.chukwuemekasamuel.com. You click on mathematics, you click on trigonometry, okay, and you'll see. So exterior angle, because sometimes you need these triangle theorems, it is important. Okay, especially for this. So to save time, so x is equal to 31 plus 58. Reason: exterior angle of a triangle is the sum of the two interior opposite angles. That's the reason. It's a triangle theorem. So this will give us 89 degrees. That's it, 89 degrees. Okay, question 15. We are getting there, folks. We are getting there. We are getting there. I know some people will say, oh, how many questions is Mr. C solving tonight? How many questions? I don't want to say how many questions. But don't worry, we are getting there, okay? We are getting there. Question 15 is WASSCE. WASSCE, multiple choice. So we have this. We have a tangent. We have this here. PCT. PZT. Okay, and then XY. XY. So we have here we have X degrees. Here we have Y degrees. We have the center O here. We have 2x minus 43 degrees here. 2x minus 43 degrees. And then we have here y plus 17 degrees. Y plus 17 degrees. Okay. It says in the diagram, angle ZXY is y degrees, angle ZYX, okay, is y plus 17 degrees, angle PZX is x degrees, and angle YZT is 2x minus 43 degrees. Find the value of y. Find the value of y. So, this is a nice case of, and the theorem we did today, okay, theorem 8. Angle between a tangent and a chord is equal to the angle in the alternate segment. So, x is equal to y plus 17. Y plus 17. Angle between a tangent and a chord, you draw the triangle, is equal to angle in alternate segment. Okay. You can call this equation 1. Equation 1. They want us to find y. That is, I'm not going to find x. I am just going to find y. Okay. But if you want to find x, of course, you just add 17. Then the next one is 2x minus 43 is equal to y. 2x minus 43 is equal to y. Call this equation 2. The same reason, angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, so from equation 1, our x is y plus 17. So 2 times y plus 17 minus 43 is equal to y. Okay, so 2y plus 34 minus 43 is equal to y. So, excuse me, 2y minus y is equal to 43 minus 34. So y is equal to 9 degrees. Okay, 13 minus 4 is 9, yeah. Y is 9 degrees. Alright, question 16. Don't worry, we are getting there. We are getting there. We are getting there. Question 16 is JAMB. The JAMB, and this one looks funny. This one looks a little bit funny. So you have this. We have two tangents. We have center O. We have X here. We have Q. We have P. We have R. Okay, it says here PQ and PR are tangents from P to a circle center O. Okay, these are tangents drawn from the same external point. Okay, same external point. As shown in the figure above, if QRP is 34 degrees, find the angle marked X. So QRP, angle QRP is 34 degrees. Find X. QRP. That means we have to draw a triangle. We have to. Okay? QRP. So this is what they say is 34 degrees here. 34 degrees. QRP. Find X. Alright. This will not be angle between a tangent and a chord because this didn't reach, this stopped at the center. Okay? Please don't come and say, now if this was like this, because some people might say, oh, this will be 34 degrees. And the thing is that in JAMB, you see the option. You see the option there. So look, if this was like this, here, then this would be like, it will have to reach to the end. It has to reach to the end, 34. It has to reach to this end, 34. It has to. It doesn't have to stop at that center, circle center, no, it has to reach to the circumference. That means angle in the alternate segment. So please, 34 is not X. No, please. Okay, it has to reach to the circumference. So take note of that. We know that this is congruent to this, drawn from the same external point. Okay, the theorem, two tangents drawn from the same external points are equal in length. Okay, so this means that this is also 34 degrees. So angle RQP is 34 degrees also. Two angles drawn from the same external point are equal in length. So base angles, you can call them base angles of isosceles triangle. Alright, now this is 90 degrees anyway. This here is 90 degrees. This is 90 degrees and this is 90 degrees. So angle OQ OQP is equal to angle ORP, which is 90 degrees. Reason, radius is perpendicular to the tangent at point of contact. Radius is perpendicular to tangent at point of contact. So 90 minus 34 gives us 56. So this is 56, this is 56. Okay, so we can now find x. So considering triangle, OQR, or let's say ROQ. Considering triangle ROQ, x plus 56 is 180 degrees. Reason, sum of angles of a triangle. So x will be, x plus 112 is 180. So x is 180 minus 112, and that is 68 degrees. X is 68 degrees. That's it. 68 degrees. That's it. Okay? So look at all these reasons. Question 17. Don't worry, we are getting there. Okay? Question 17 is CSEC. Okay, let's draw this circle. CSEC. So we have a tangent. Okay. Yes. Okay. We have another tangent, because it's good to draw this well. It is good to draw this well. And I probably didn't draw this right. Okay, that's not bad. Then we have this here, touching this tangent. Another one here. A cyclic chord, which we may or may not use, I don't know. Then we have this going like this. We have a radius, the center O. We have another radius. So two radii. And then this angle right here, that angle is 114 degrees. So we have FAE. And this angle is 114 degrees. Then we have BCDG. Then we have 18 degrees here. Angle between the tangent and the chord. This is 18 degrees. 18 degrees. Okay. Which we'll see whether we'll use. Okay, it says here The diagram below, not drawn to scale, shows a circle with center O. The points A, B, C, and D are on the circumference of the circle. EAF and EDG are tangents to the circle at A and D respectively, right? AOD is 114 degrees. AOD is 114 degrees. And then CDG is 18 degrees. CDG is 18 degrees. But it says here, calculate, giving reasons for each step of your answer. The measure of I is CD, ACD, II, AED, AED, III, OAC, IV, ABC, ABC. All right, folks. ACD. Okay, so what should we do? ACD. Now, do we notice something though? Angle between a tangent and a chord. Yeah, but that will give, now this here will be 18 degrees. Yeah. But let's see if we can find ACD first. So we can get this one, get that. There are several things we can do. Okay? We can get a lot of these angles. I'm just trying to see what might be a quick way to get, to get this. But we can get a lot of these. So here, this is 18 degrees here. 18 degrees here. Okay, you know why? Look at it here. We have this chord and it has this. So this 18 degrees is this 18 degrees. That's what I wrote. Okay. Angle CAD is 18 degrees. Reason, angle between a tangent and a chord is equal to the angle in the alternate segment. Okay, but that is actually not, that's not what we want, but that's no problem. We can get what we want. Here, if you look at this is 90 degrees. Angle, this is 90 degrees, the whole of this. Angle ODG is 90 degrees. Reason, radius is perpendicular to tangent. at the point of contact. Radius is perpendicular to tangent at the point of contact. So that means that we can get this angle here, okay, which will be 90 minus 18. To get that angle there will be 90 minus 18, because the whole of here is 90 degrees. So 90 minus 18 will give us this angle here. You guys understand what I'm saying? So because this is the radius and this is the tangent, this is 90 degrees. 90 minus 18 gives us this. So angle ODC is 90 minus 18, and that is 72 degrees. So this is 72 here. This here is 72 degrees. Okay, that angle. Then, of course, we can get this angle here. We can get this angle here. But you know, we can get that angle here. There might be an easier way to do it. Because CSEC questions are normally easy. If you ask me, no. If you ask me, which does not require a lot of. Okay, let me stop there. But do you understand what I'm saying? Now we can get this angle here. We can get this angle here. Base angles of isosceles triangle. Okay, we can get this angle is equal to this angle. Not the 18, okay? Angle OAD is equal to angle ODA. We can call that X. Base angles of isosceles triangle. Okay, so when we do that, we now have that considering triangle, let's come here already. Considering triangle OAD, X plus 114 is 180. So 2x is 180 minus 114. 10 minus 4 is 6. 7 minus 1 is 6. So x is 66 divided by 2, which is 33. So this is 33 here. Yeah? This is 33. And this whole is 33. When you now do 33 minus 18, you get this small. Question 18 is JAMB. Question 18 is a JAMB question. We have the circle.